Hey guys, back for kind of just continuation of what we were doing today. I'm doing it today, Tuesday, but for you guys tomorrow on Wednesday, just writing the dissociation equations as well as soluble and not soluble. It was good to see you guys. I truly have missed you guys. Here we go. I don't know. I might have told you these jokes. If I do, I'm sorry. What do you call a pig that does karate? Pork chop. Oh, that was pretty good. Maybe I've done that one. What happened when the pig pen broke? The pigs had to use a pencil. And the last one, why did the farmer call his pig Ink? Because it always ran out of the pen. Okay, there you go. And you go, those aren't very good either, and you'd probably be right. Okay, what I want to do today is, okay, and you guys remember the assignment that's due today, Wednesday, for you guys, is the two handouts on the balancing, the questions from the book, and the quiz on chapter 7, okay? But now I'm going a little bit further on this handout right here, dissociation equation. So I'm just going to do a couple more of these. This will be a really short lesson, but just a little bit more practice of what we were doing. Okay, so dissociation equation. So I did 1 and 2 in class. So number 3, so lithium phosphate. So again, what I have to do is I have to go back and look up their charges and write the correct formula. So lithium is a 1. So if I look these up, lithium is a 1, and phosphate back here is PO4 as a 3. So if I cross those over, what I get is Li3 PO4. And it's a solid. So this is just like what I did in class. And we're going to put this in water, and it's, again, the word they use in chemistry is it's going to dissociate. It's going to break into its two parts. And what's always tricky are these subscripts. So if the subscript is part of a polyatomic ion, it will remain a subscript. I'm sorry, yeah, if it's part of a polyatomic ion, like this 4 is part of phosphate, it will remain a subscript. But if not, it'll go to the front. So then 3, because it's not part of a polyatomic ion, goes to the front. And details are really important in this chapter. So remembering that this is a positive 1 like this, and then you have PO4 negative 3 like that. So that's the dissociation equation. This is a strong electrolyte. It would conduct electricity. Okay, then the next one is copper 2 hydroxide. So again, just like we talked about in class, on Google Meet, okay, what is this? This is the charge. This is the charge. So copper is a 2. And then hydroxide, which again, if you've forgotten, you can look it up. Hydroxide is right back here on the periodic table, and it's a 1. And this is where it's really important to put the polyatomic ion in parentheses. So what you get is CuOH2. What would be wrong is to write it like that. And the difference between the two is here, the 2 is distributing to the H and the O. Here, the 2 is going just to the H. So that is wrong. Okay, so again, I want to show this to just dissociating. So it's going to break down into copper and into 2 hydroxides, because this 2 is not part of a polyatomic ion. It goes to the front. Okay, and I'll let you guys try 5. Let me do 1 down below. So number 8 is CuNO3 Now, to me, if you can name this, you can do the dissociation. This is a solid. And this is copper, which is a type 2. So it needs a Roman numeral, a little review. NO3 is nitrate. Okay, now remember, to review, how do we figure out the Roman numeral? Well, we looked up the charge on the anion, the second ion. So nitrate is a 1, which again is on the back of the periodic table. So you go 1 times 2 is 2 divided by 1. And you didn't really have to do that here, but to me, that tells me what this is going to dissociate into. Copper 2 and nitrate. So I've got copper 2, and you've got to show the charge and you got to show the state. The 3 is part of a polyatomic ion, so it will remain a subscript, but the 2 will go to the front. So it'll be like that. Okay, and then the other thing that I wanted to go over with you guys was from the book. So number 11, and this is where we use the back of our periodic table. And so I'm on number 11 in the back of the book. We did A through D. So let me just pick up. So again, what we're doing here is we're predicting if this is going to be soluble or not soluble. So I'm going to erase this. Okay, so remember what we said. If something is soluble, you kind of think the S goes with that, but actually AQ. That means it dissolves. And if something is not soluble, that means it's a solid. Okay? Okay, so we're going to be using the table on the back of our book. So letter E, sodium phosphate. And all we're doing is this soluble or not soluble. So you have to have, so here's your periodic table. You go to the back, it's right here. And again, remember I start with the second ion, phosphate. So I look up phosphate, which is right here, alkali ions, and I go up here and I check the alkali ions, and they're sodium. So this would be soluble. That means this is AQ. It means it dissolves. Okay, the next one is silver 1 chloride. The way I taught you to name this, we would have just called it silver chloride. So again, I start off with the second ion. So I look up chloride, which is right here. Then I go back to silver, and there's silver in the first one. This is not soluble, so this one would not dissolve. This one would be a solid, like sand. Okay, and the last one is iron 2 carbonate. So again, remember I start off with the second ion, so I go back here, the anion, there's carbonate right there, and now I go back to iron 2. So it says alkali ions, which is up here, LiNAKRBCS. It's not iron, so any other cation. So this again would be not soluble. Solid. So we've really come to the place where we're using the periodic tables a lot. So, okay, so you guys know what's going on. Again, we just got to make the best we can of a bad situation. And I'll see you guys on Thursday. We'll do some jokes. We'll learn some chemistry. Doesn't get much better than that. See ya.